The other metal you may come across is aluminum. A little different look. We don't do a lot of that, except with our metal castings. Some we cast aluminum castings, and we also have a spool gun on the MIG weld. I don't have one here, but at school we have one that can be candied, quick, and it's like a big, blaster thing. I shouldn't call it that, but it's heavy-handed. But if you want to do delicate stuff, the TIG can also do aluminum. Now, in the olden days, I shouldn't say olden days, but they had, there were two colors of tungsten electrodes, with red and green. Red was 2% thoriated, and green was pure tungsten. You used red, 2% thoriated, with steel and bronze and a lot of other things, and you ground a point to it. With the aluminum, what you do with the green one marked green, you would just leave it without a point and actually strike an arc with it direct current electrode positive briefly to melt a little ball on the end, and you would use that with the aluminum. With newer kind of tungsten mixtures, one we have at school is an E3, I think it's what you call it, what the welding supply place had. Seems to work with a point with the aluminum, okay. Depends on the type of electrode, but it does, when you're working with aluminum, you're using AC current. Also with aluminum, it's not a bad idea with all metal stuff. Make sure you have ventilation. With all the metals you're welding, the fumes, you don't want to be closed up in a tight space without any airflow. You don't want wind blowing and knock the shielding gas away, but you don't want to have building up of fumes that are bad for you. It's also not a bad idea to wear a respirator. This is a disposable kind of one for welding use. Anyway, and your helmet and all the other. This is a little thicker material. Turn the amperage up to like 97, 100 amps. Again, make sure your metal is relatively clean.
So here's kind of what that aluminum looked like. Probably need a little bit more practice, of course, but make sure the metal is as clean as possible when you start out can be very helpful. All right.
Adjusting the resharpening the electrode, or adjusting it first up. You can loosen up this, and you can get that electrode to come out. You don't want it out that much, so you have about sticking out that much for an in tight spot, or even back farther, and loosen this back cap.
Electrode stick out should be 3 times the diameter of the electrode. So for a 3/32, that'd be about 1/4 inch or so. All right.
Anyway, but I'm going to loosen it up and have it come out. Get this out of the way. So I've completely bunged up this. So that can happen overheating it, but also like using the aluminum. And then also if you dip it into the metal, if you actually get it too close, you want to grind that. And you don't want to grind it like this, so the lines are going this way on it. You want to grind those lines in line with it. A lot of times what I'll do, or what I've been told, is to take that little tip right off. Just a little bit. So it's kind of slightly blunted on the end. Because that little tungsten part at the end will just melt off and fall into the molten puddle. Also the tungsten electrodes, I think we have E3s, which is, I think was what they were selling at a local place. I've got some 2% lanthionated, which is this bluish kind of end to it. I also got some seriated, which is kind of worn off, but this is gray. Don't grind. Okay, pet peeve. Some people, this end gets messed up, they grind the other end, and then we don't know what it is. Also, there's a kind of a close-up, I hope close-up, so it's not blurry, of the ground tips. This one is very fine, so you get less penetration, but very good for thinner stuff. This one's very blunt, so you get a bigger penetration, deeper penetration. I found that a lot of times with myself too and students, when I have a finer tip like that, I end up melting it quicker, and the students end up using up the tungsten quickly. So they're not supposed to be they're not supposed to get used up. They're supposed to be, the filler rod is used up. This is not the filler rod. So those. I found that the blunter ends last longer, for most reasons, unless there's some specific those. If you've gotten into this and you get more into it, it gets very complicated. But let's try to keep it simple. So basically, to change out, I think that's a 330 seconds in there. I can loosen up this back cap, and most times you're going to come across the torch. Hopefully it looks somewhat like that, about 3/16 for 330 seconds. It's 3 times the diameter of it sticking out. That can vary depending on what you're trying to do and for how long. But so I basically have that tight so that stays in there. To loosen it, I turn this to loosen, and then I can slide that out. Be careful if it's hot. This should be securely in place. Be careful again, this is a ceramic. It's good for heat, but if you smack it down on the table, that'll shatter. If that happens, come and get me or the lab tech and we'll replace it. Don't keep using it with the tip broken off. You'll destroy other parts of it. You'll keep melting more and breaking more. So if something goes wrong with something, let me know. Anyway, so that's a little bit about TIG welding.